So I'm going to start recording so you guys have access to this recording later on. I'll go back to sharing my screen. So let's see here. Out of the way. All right, so here, as you know, I've been working. The reason I didn't let May use the Farnsworth house is because that is actually what I will be using to, demonstrate for everyone here. We can begin tonight. Why don't we start with windows? A lot of you have, well, for example, the Farnsworth maybe isn't the best example, so I'll turn off a couple of these layers and basically just start from scratch. The Farnsworth not being a good example because it's essentially just columns and a window and tiny bit of walls in the center. There's not really a lot there to model, but a lot of you have a lot of punched openings. Josh, your house has a lot of like these angular portals. So this is basically a demonstration on how to model door openings and window openings. Okay. So to get started, we'll basically begin by modeling a plain wall. So I'll start in my top view. And we talked a lot about different ways to model walls, but for this demonstration, I'm just going to use a simple box command. So let's say 5 inches by, I don't know, 10 feet and 10 feet. So let's jump over to this perspective view. So like most things in Rhino, you have to first begin by modeling some curves or lines that basically set up the framework for you to model more complicated elements. So why don't I ask the class, what are probably some commands that you would probably use to create an opening through a solid, basically this wall? Yeah, Boolean difference is the obvious one. I actually learned a new command today that I'm also going to show you, which I think everyone will love because Boolean difference can be kind of annoying sometimes. So this one is definitely, I think, going to impress a lot of you guys tonight. So I'm going to turn on my construction lines layer. And I'm going to work in my construction lines layer just to keep my files and my objects a little bit more organized. So I'll start by creating a simple rectangle. We'll start with a door. And by using the rectangle command, we'll just basically make the outline that will be the rough opening for the door. You'll see here in the rectangle command that there are several options here, and one of them being vertical. So when you open the command initially, the rectangle will happen on the X and Y plane. But if we click vertical when we start the command, that will allow you to work in the vertical direction. So it'll ask for an end of the edge. So we'll say, okay, doors are typically 3 feet. We'll enter 3 feet here. And then we'll enter the height, which will be, let's say, doors are typically 6 feet, 8 inches high. All right, so we have the basic outline of our door opening. So at this point, most of you will probably go ahead and use the extrude curve command to make that a solid box and then go and do the Boolean union. This new command is called make, or what was it? Make whole. So the make whole command is essentially combines the extrude curve and the Boolean all in one. So you could do the same thing with less steps. So it's going to ask me to select my planar closed curves, which is the door here. And I'll hit enter. And then select a surface or a poly surface, which is my wall. So now all I need to do is drag in either direction, and I need to drag past the boundary of my wall. So I'll just go ahead and click, and boom, there you go. You have an opening. Olivia just said that this blew her mind, and I agree, my mind was also blown today, because for the past 5 years, I've been doing the Boolean difference command, and I think this one is a lot simpler. Of course, you probably would want to still use the Boolean commands for more complicated, types of modeling, more complex shapes and forms, but for simple openings and walls, the make whole command is a go-to. So similarly, let's do a window. So similar thing, we'll make sure we click vertical. We'll say, let's do a 6-foot window by a 4-foot window. And I'll move that up, let's say 3 feet. All right, that is the window that I want to create. So I'll do the same thing, make whole. And I'll extrude that beyond the surface. And now I have my window opening. So let's say that you've created a window opening in your model, and hopefully you will use the plans and sections that you've imported into your model to sort of align where your window should be. But if by any chance you mess up and you model it and do the whole thing in the wrong location, what's nice about that make whole command is that I also learned that there is a command called move whole. And what move whole obviously does is move the whole. So we'll do move whole, and it'll ask me to select the holes in one planar surface. And all I would need to do is select the edge of the hole here. And I hit enter. And now I can select a point to move from, and I can move that hole at any point on this surface for the wall. Unfortunately, it does not work for the door, because basically what Rhino is doing right now is it's reading, it's not reading this as a whole, this opening as a whole, because it is open on one side. So it's technically not a hole, it's just the shape of the wall. Okay, so of course, making the openings is step one to that.
I was trying to make it. The first one is rectangle. After rectangle, it go up because I can cut through.
You can't cut through. Why don't we talk about that when we do our one-on-one session, and I'll show you, I'll run through the command again. Okay. And we'll also have this recording up on Canvas so you can reference back. Yeah. Okay, yeah. I don't want you to have to rush and try to do it right here in class. Yeah. Okay. Okay, so as I was saying, we have our rough openings. So now we need to figure out how to model mullions, how to model glass, and how to model the doors. I think let's begin with windows or mullions. So of course, most of you will have to model to a certain level of detail, and mullions will generally be expected. So the way I would do that is by using, again, the idea of starting with a set of curves as your framework. Begin by using the rectangle tool and setting up, well, let's do the vertical again. Make sure we hit vertical. We'll select the endpoint here and we'll move up. So that's step one. Next thing we'll do here is we need to essentially give the mullions a thickness. Typical thickness for a window frame is about 2 inches, but of course you'll need to look at the drawings for each of your buildings to define that dimension. So we'll do offset, yeah, just offset. And we'll enter 2 inches. So now, as you guys can probably guess, we would use the extrude curve command to extrude that surface, making sure we have our solid selected as yes. And we can extrude that surface to the thickness of the wall. And that will give us our window frame. And then we can create an actual glass layer. And we can look at a bunch of different surface commands that we can use. Obviously, glass has a thickness, but for the purpose of this project, a simple surface should be fine. So we'll do surface from 3 or 4 corner points. And then I would go and select the midpoint of your frames. So midpoint 1, oops, midpoint 1, midpoint 2, midpoint 3, and midpoint 4. And that gives us our window surface. And I always like to make my window layer blue, just because. Now, some of you probably have windows that have a lot more complex mullions. For example, if we look over at Canbar across the way, or even these windows here, it's not just a singular window, it's maybe a curtain wall. So how do you make the mullions for that? Well, it's a similar process. You would essentially draw out all the mullions and do that extrude curve command. So I'm going to extend this wall out here to, how are we doing on time? All right, we got 15 minutes. So I'm not going to do that. Maybe I'll just do it very quickly in an elevation view. Let's go to front. So for example, if I have a curtain wall or a large window, let's start with our offset, 2 inches. And let's just begin by, drawing what our window might look like. So maybe it's this funky window. That maybe has some triangular portions to it. I don't know, just making it up here. And we'll use these sets of lines to make that extrusion. But first we need to clean this up a little bit. So first I need to connect all my lines. So I can do that by using, for example, the extend command. And over here, I would use the trim command. So I'll select my cutting object, which is that boundary, hit enter, and select that curve. But now I also need to remove this portion of my lines, which are located here, 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 end up here. So I'm going to do the trim command. And this time I'm just going to highlight everything. And I'm going to select my objects to trim. So just be sure to select the portion of the line you want to remove. Hit enter. And now the last thing you will need to do, you'll see now that I did that, these are all individual lines. To make sure that the extrusion happens as a solid closed object, what I'm going to need to do is essentially connect all those lines, and I will do that by using the join command. So now you'll see each of these are a closed loop. So now I can go ahead and do my extrude curve command and give that a thickness, say 4 inches. And those would be my mullions. So essentially you would do the same step for the glass, use that surface command, or draw a line, a rectangle that represents, the boundary of that glass. And use, for example, the patch command to create that surface. So now let's talk about stairs in the last 15 minutes we have here that I've allotted for this demo. Sorry, this demo. I am going to, let's hide all of this. And I want to show you how to make stairs, using your sets of drawings. So here I've created, you'll see some stairs for the Farnsworth house. And I created these basically by tracing the drawings that I've imported into Rhino. So at this point, all of you should have something that hopefully looks like this, and hopefully maybe a little bit more, but your plan intersected with your elevations or sections. So you'll see here, I'll essentially just model this again. So let me just delete the stairs that I've drawn, and I'll turn on my construction lines. I need to begin by tracing my steps. So I can do this, and because these stairs are very simple, some of you might have very complex looking stairs. The Farnsworth is very simple. So I'll show you how to do that very quickly. And I'll start with the box command. So let me make sure I'm in my stairs layer. I'll rename this to stairs. So I'll begin by, notice here how I have created a set of construction lines. I have a curve here that represents where the essentially edge point of that stair is, and where the end point of that stair is. You'll see here in my top view, that line extends a little bit beyond to represent basically the boundary, that left boundary of the stair. So let's begin. I'll start with my box, and I'll select that endpoint, and I'm going to move over. Let's work, of course, in all parent intersection. That's not what we want. Let's turn our intersections off. Okay, let's try that again. So make sure we're hitting the end point. So I essentially told Rhino this is the start point for my stair. If I hover over to my top viewport, now I can essentially trace with my box command the extent of that top stair. So I've, in plan view, set up that boundary, and now I'll move back into my left view and essentially just trace the drawing here. So that is my first step. So if I remove my backgrounds, I'll go over to my perspective view, that's stair 1. So I'll turn my backgrounds back on. This top stair is a little bit longer because it also acts as a landing. So that's why that one seems a bit longer than the rest that I'm about to do. So let's do that again. This time I'm just going to again, trace. We'll do it in a plan view and section view at the same time. Now if I turn my backgrounds off, we have stair 2. At this point, my stairs are, or should be, all the same dimensions going down. So I can just begin to copy these. So I'll just do copy. And I'll copy from the end point of my previous stair. There we go, we copied those. Now what I did here, you'll see I've essentially traced the stringers of the stair, the thing that, you know, holds all the treads together. And like every other command or every other sort of process in Rhino, we start with curves and we get later paid with surfaces, right? So if I do that extrude command, extrude curve, and let's say that is 3 inches wide, I now have that surface. And if I look at photos of the Farnsworth house, I don't know, let me pull something up. I don't know if you guys can see my screen here. Go to images. You'll see here that the stringers aren't located at the very edge, but they're somewhat inset a little bit. Now my drawings don't exactly tell me how far they are. So at this point, I think I'm fine to sort of give a rough guess as to how far in that is. So maybe I'll just move that, let's say 6 inches. And now I don't need to remodel this. I can use my mirror command to essentially just copy this to the opposite side. And there we go. That gives me a set of stairs for the Farnsworth house. Now that's pretty simple. Some of you probably have more complex stairs and are probably wondering what's a great way to model without having to copy and paste every single tread. So let's do an example with how to do that. And let's go to our front view. So over here, I have essentially modeled, in the US, as some of you know, a typical tread depth is 11 inches and the riser is 7 inches. So I've essentially modeled that here. And what I'm going to start by doing is I'm going to scale this line that represents the slope of my stairs. Or first, let's begin by essentially saying, okay, where is the first floor and where is the second floor? So this is representing my first floor. And maybe I'll copy my second floor construction line, let's say 10 feet. And I'll make those red to represent my construction lines. And I'll move that control point all the way over here to extend that line. And now I'm going to scale this line until it intersects what is my second floor. I'll turn my intersection on. Okay, so this is the first floor and this is the second floor. So you're probably already aware that we probably would likely start with the box command. And I've set up this height and this length to represent that boundary of our stair. So we'll say, okay, a 4 foot long, oops. Or let's go 6 feet. And we'll click that top point. Okay, so we have one stair. So we could, of course, copy and paste them all the way up, but what's an easier way to do that? We could actually use the array command. So I'll type in array, and it'll ask me to select my objects to array, which would be my tread here. And I'll hit enter. Oh, sorry, I think that's not the array along curve. Okay, sorry, the command is array curve. So it'll ask me my objects to array, enter, and it'll ask me to select a path curve, and that path curve being essentially the slope of my stairs. So I'll select that. And I'll see this dialog box come up. And it'll ask me the number of items to array. And I'm not quite sure, so maybe we'll just enter, let's start with 10 for now. And we'll hit, oh. So we want most likely these to connect from one another. So we need to input some more information. So let's see here. What is our distance from point 1 to point 2? Essentially, what is our X distance and our Y distance? We might need to do some math here. So our X distance, we can use the distance command to take some measurements. So using my smart track here, and I'll select that point. And that is, let's say, okay, we'll just round it to 17 feet. So that is our X. Let me write that down so I don't forget. And we need our Y. So we'll do distance again. Oops. And that being, of course, 10 feet. And we know that this distance is, I believe I put it as 1 foot. 11 inches. Yes, but I think I actually drew it as 1 foot. So we'll keep with 1 foot for now. So let us go back to our array command. All right, so we'll select our object to array and our select path curve. And now let's select the distance between items. And we'll do 1, assuming that's 1 foot. And there we go, there are our stairs. I'm not quite sure why they went in that direction, but we can always quickly just move that. And there we have a set of stairs without having to copy and paste each individually. Does anyone have any questions about what we've seen so far? Yes. Do you want to share your screen? Actually, well, you're not on Zoom right now. If you can quickly, that way you can share your screen so we can see what you're talking about. I'm going to stop the recording here.